Hi, my name is Maria, and today I want to be discussing the ocean waves and tides and the effects on the coast. Let's begin. I will be talking about the table of content. Content is pretty easy. I will be discussing the waves in the coastal process for the waves and the tides in the coastal process for the tides and how they affect the ocean. Not like affect, but like how they rely on the ocean and you know to begin with, I'm going to start with the ocean basics and how they are formed, and I will end lastly with the coastal process. Waves generally begin as a disturbance of some kind, and the energy of the disturbance gets formed into to form into some sort of wave. Movement is caused by energy that moves through the water. And waves have many different types of forms, and I will be discussing that in my next slide. I also want to discuss the components to a basic wave. We have a still water level where the water surface would be if there was no waves present and the sea was completely calm. The crest is the highest point of the wave, and the trough is the lowest point of the wave, and the wave height is the distance between the wave and the trough. The wavelength is the distance between two identical points on a successful wave, for example, crest to crest and trough to trough. You never go the opposite way. You never do crest to trough or trough to crest. Crest. You always do crest to crest or trough to trough. You never mix them around. And the wave steepness is the ratio of wave height to length. And if the ratio is 1/7, the wave will get too steep and it will break eventually. And I also want to talk about the wave motion, and that's the period, the frequency, and the speed. The period is the time it takes to for it take the time for two crests to pass a given point. The frequency is the number of waves passing the point in a given amount of time, usually waves per second, and the speed is how fast the wave travels, or the distance traveled per unit. And to find the Celsius for it is a wave time frequency, and you will find the longest wavelength and the fastest of the wave. So wavelength time frequency will give you the longest wavelength that you could get in a wave. Okay, moving on to the next slide. Oh, and also the movement is caused by energy that moves through the water. It transport energy through the water, making the wave. Okay, moving on to the next slide. The different types of waves. We have capillary waves, shallow and deep water waves, atmosphere waves, force waves, wind waves, and breaking waves. And this right here is a picture of a capillary wave. And there's more waves, but these are like the basic ones that like you should know about the ocean waves. Okay, the common waves you should know is the capillary waves, the wind waves, and the breaking waves. And I'm gonna discuss all three of them. This is an example of a capillary wave, like I showed you in the previous slide. And then this is an example of a wind wave and an example of a breaking wave. And I will be discussing the three waves in this slide. So a capillary wave, it has ripple that starts from a gentle breeze, and it has a round crest with a V-shaped trough, and the wavelength is less than 1.7 centimeters, and the wavelength exact is 1.7 centimeter, like I said, and the wave translates from a capillary wave to a wind wave. And also capillary waves are wind blowing across the water surface, creating a little disturbance, like how this picture is shown right here. Okay, moving on to wind waves. Wind waves is a wind. It's a wind wave is a water surface wave that occurs in the free surface of the body of waters, and wind waves result from wind blowing over a fluid surface, and where its contact distance in the direction of the wind, and is also known as a fetch. And right here is an example of the wind wave. Okay, moving on. Moving on to the breaking wave, right? This one right here. The breaking wave are formed when a wave collides on top of each when they collapse on each other, and the breaking of the water surface wave happens anywhere on the surface of the seawater. So, however one could see a breaking wave surface of breaking water surface wave, and they're mostly common on the coastline since the wave fire normally amplified in the shallow water areas. Like you could see the breaking waves on a coastline when the shallow water is amplified. Okay, moving on to the next slide. Oh, and they all these three are curated by the factor between waves and surface waves. Okay, tsunamis and storm surges. I'm sorry for the bad spelling on this one, but let's get move on. Tsunamis and tidal waves they have no relations to one another. Tidal wave is a shallow water that is caused by gravitational intention between the sun and the moon, and tsunami is an ocean wave that is triggered by underground activity. So they both tsunamis and tidal waves are not the same, and tsunami is a type of wave. And tides is a type of wave, but we will go into more detail into that later. They are caused by underground disturbance, earthquakes, volcano eruptions, and landscapes. A tsunami has a long wavelength of 100 and 200 kilometers long. A volcano eruption can displace a great volume of water and generate extremely destruction. A tsunami can cause. And so storm surges are caused by strong winds and pressure, and this is an example of a tsunami and a storm surge. Moving on. I also forgot to mention when the two like plates begin to slip between a break, it can cause an earthquake and a tsunami wave to start. So moving on to the next slide. The formation of waves. This is how waves are made. When blowing across the ocean, it spins in a circular motion. Waves break as they approach shore, and they create swell and smaller waves. The part of the wave is pushed down. Energy passes through the water, causing it to move in the motion. Wind blows through the surface, transferring energy, and it becomes a capillary wave. With a strong wind, they could become wind waves, and have more energy, and they will also become a gravity wave that is completely different from a regular wave. Before we move on, I wanted to also talk about atmosphere waves. They form in the sky at the boundary between the air masses at different density. They often create ripple effects in the cloud. They have nothing to do with ocean waves. They kind of do, but they show the different types of waves we have outside of the ocean. And atmosphere waves are formed in the sky, and they often create ripples effects in the clouds. How capillary waves create ripples. Okay, moving on. Oh, and this is an example how waves are created with the wave height, the wavelength, and the wind, like the wind and the wavelength. Okay, the coastal process of the waves are beaches. They move beaches sediments. They transform beaches shape. The rise of the sea level can cause coastal erosion. A coastal process is caused by the wave. Sea level rises. They give out strong waves and they give coastal flooding. And for all that to happen, it could go into the wavelength. And if to learn more about the wavelength, I talked about it previously in a podcast with Michaela Nava. It will be linked below the portfolio. I'm going to move on. So we're moving on to tides and how they affect the coast too. Okay. Okay, tides, they move sediment, beach sediments too. They, trans- they transport beach shapes. Okay, now I'm going to be talking about tides and how they affect the coast. Oh, okay, let's go back. Okay, tides are a type of wave, and the gravitational pull of the moon and the sun can cause a tide. This is an example of how the high and the low tides are made from the moon, and they combine. It combines the gravitational pull of the sun and the moon. They are also known as gravity waves, and they are the longest waves we have. And tides are the regular rise and fall of the sea level. These are the four different types of tides we have: low, high, spring, and neap tides. And this is an example of each tide. This is a low tide, a high tide. I can this one right here is how neap tide is created, and a spring tide is created. Low and high tides are caused by the moon that pulls in the close. It pulls in that closest to the like of the furthest away. And like wait, ignoring that part. Okay, high tides are caused by the moon pull, and can cause tidal force occur. It can cause tidal force to occur when the moon is closer to the farthest and form from and can and water covers too much shore after rising the high level. It will cover too much shore after the high tide is rising to the highest level. A low tide. Low tides are are areas between high tides. They occur when trough reaches a particular location and water moves away from the shore and is to the lowest point. The moon has been more influenced on the sun because it has been closer, and it can cause belingenes. I'm sorry if I'm pronouncing that wrong. And also, high tide can cause tidal force. And last to know is that low tides, water moves away from the shore and it's at its lowest point. And so, like, you don't really notice low tides because they're at the lowest point of the shore, like how I showed you in the previous slide. Okay, how I showed you in this slide. This is the low tide and this is the high tide. Right now, I'm going to be discussing the spring and the neap tides. The spring tides take place during a new or full moon and occurs about twice a year, and it has nothing to do with the seasons. They form when the Earth and Sun and Moon are in alignment. When the Earth and the Sun and the Moon are like together and they're aligned in a straight line. And keep in mind that tides are caused by the gravity force of the moon and tides, the gravitational force. And near tides are tidals that occur at the first and third quarter of the moon when the moon appears as half full. So when the moon appears at half full, near tides are caused and they occur. and they will only occur 7 days after a spring tide. And a neap tide occurs when the Earth and the Sun and the Moon form a right angle, 90 degrees, and takes place halfway between the spring tide when the Moon is at its worst and last quarter. And the coastal process for the tides is the sediments. It could change like how we learn about the ocean sediments. The sediment matters that settles. Sediments is the matter that settles at the bottom of the ocean. And you can't really see this picture, but this is the sediment at the ocean, and how it's formed into the deep ocean and how it affects it. And the two main sources is these are the two main sources. And yeah. Alright, if I could pause this. And I also wanted to show you sorry about that. Also I wanted to show you a picture of the wavelength and how you would describe it. So this is the crest, and this is the crest is on the top and the trough is on the bottom, and the wavelength. This is how you measure the wavelength from side to side, and the amplitude. So the wave height is the vertical distance at the crest, and the trough is the vertical distance of the crescent trough. And the amplitude is the height of the wavelength, space between the still water and level of the crest. And to measure it, you measure from crest to crest or trough to trough. You never do it to crest to trough or trough to crest. And the still water level is the average water surface elevation. And these are different types of pictures of the wavelength. This is another example of the wavelength. And yeah, that's all. Oh, and so you measure crest to crest or trough to trough, like up and down or side to side. You never measure it from crest to trough. This way, you never measure it this way, because they will give you the wrong wavelength and like the wrong information for the wave. Okay, I think that's all for ocean waves and tides, and how they affect the coast. Thank you for watching, and I hope you have a good day. And I hope you enjoy this little lecture on ocean waves and tides and the effect of the coast.